This video is on exercise 1C, question 9 of A-Level Further Maths Core 1 textbook. So this question is just about a very interesting property of I, which is equal to the square root of -1. And we want to explore that a bit further than usual. And before I start doing this question, let me show you a few things about I. So let's see, because something very interesting here is going to happen. So we know that I to the power of 1 is just I, and then I squared is I times I. And I is a square root of -1, and then a square root of -1 times again itself, it just gives us -1. Like, how when we have root 5 times root 5, that is equal to 5. Now here is exactly the same. I cubed is I squared times I, and we know that I squared is -1 times I is just minus I. I to the power of 4 is I squared times I squared. I squared is -1 times -1, which is 1. Then I to the power of 5 is I to the power of 4 times I. I to the power of 4 is 1. 1 times I is I. I to the power of 6 is I to the power of 5 times I, which, so we know that I to the power of 5 is just I, and then I again times I is I squared, which is -1. I to the power of 7 is I to the power of 6 times I to the power of 6 is -1 times I is minus I. And now you may be wondering that how far I'm planning to go, but this is the last one. So I to the power of 8 is just I to the power of 4 times I to the power of 4. Of course, you can use different forms of that, different combinations. For example, I to the power of 6 times I squared, and so on. So I to the power of 4 is 1 times 1 is 1. Now the interesting thing here is that there is a cycle, because as you can see here, so I to the power of 1 is I, and then we have -1, then we have minus I. When we have I to the power of 4, we get 1, and then this just continues, because I to the power of 4, sorry, I to the power of 5 is I, the same as I to the power of 1. Let me just highlight that with a different color. So, and I to the power of 6 is -1, the same as I squared. I to the power of 7 is minus I, the same as I cube, and I to the power of 8 is equal to 1, the same as I to the power of 4. Now we can generalize that, so this can be very helpful to us later on. And there are some relations that we can write down, and hopefully I hope that it makes sense. And I can now generalize that. So from now on, if we have something in this form, I to the power of 4n, or just a number that is a multiple of a 4, then this is equal to, from now on, 1. Because, for example, when n is 1, then we have I to the power of 4, which is 1. And by the way, this is true for when n is a natural number. And we know that natural numbers are the numbers that we can count with them, like 1, 2, 3, 4, 5. And also we can have I to the power of 4n plus 1, and this case always gives us I. For example, the number 5 satisfies this situation, because 5 is equal to, when n is 1, we have 4 plus 1, which is 5. And we know that I to the power of 5 is I, and by this generalization, we can also work that out. Now, I to the power of 4n plus 2 is always equal to -1. And finally, we have let's put some commas here. And finally we have I to the power of 4n plus 3, which gives us minus I. And now you can compare each of the examples above with these relations, and you can see that all of them satisfy these conditions. All we have to do is that we have to just know the first 4 cases, which are I to the power of 1, I squared, I cubed, and then I to the power of 4. And we don't even need to memorize them, as long as we know that just what is I. And then after I to the power of 4, we can just refer to these generalizations. So, I mean, for some smaller numbers, we can just, directly, the way that I have calculated them without using any sort of formula is very easy. But when we have, numbers like maybe 50 or even numbers like 200, then it can be some of them, obviously. 200 is not that bad, but what if we have something like 253, which we will be doing in a few minutes, by the way. Right, so now let's start question 9. So we have sort of basically answered some of the questions. Part A is about, just given that I1 is I and I squared is minus 1, right? I cubed and I to the 4 in their simplest form. So I've already done that. This is I cubed in its simplest form, and this is I to the power of 4 in its simplest form. So that's part A. And part B is very similar to part A, and we have done that as well. So write I to the power of 5, 6, 7, and 8 in their simplest forms. So we have each of them here. And now let's do part C, which is the interesting part. So part C is when we can apply what we have sort of learned so far. The first one is I to the power of 100. So if we refer to these relations, the one that here is useful is this one. All we have to do is that we should do a simple division. And we see that if we do the power divided by 4, and then just based on the remainder that we get, then we can see which of these cases is true in this case. For example, here when you have 4n, that means that that's when your remainder is 0. And we know that 100 divided by 4 gives us 25, which doesn't have which has a remainder of 0. And in that case, this is the first form, and we can simply just write down, okay, this is 1. That's it. Or we could have done another method, which doesn't, work all the time, because sometimes it just is not that helpful. For example, we could have written this as I to the power of 4, then I to the power of 25. And we know that I to the power of 4 is just 1, then 1 to the power of 25 is 1. That was, another method. But as I said, it's not the best method. But for some nice numbers, it works very well. You don't need to divide the numbers. But yeah, it's not the best way. Now, let's just, do the second one, which is 253. So if you divide 253 by 4, I'm sure that this won't have a remainder of 0. So we will get 63, and so we get 63 and a remainder of 1. So the thing we get is 63 times 4, obviously, and plus 1. So that's what we get. And this simply tells us that this is the second case, this case, where we have 4n plus 1. That's when the remainder is 1. And this tells us that in this case, the answer is equal to I. So, yeah, this was another case. And this is a case that the first method the second method that I wrote here, that's I to the power of 4 times 25, and then we can work out the value by using that method, doesn't work really well here, because 253 is equal to I think 11 times 23, and in that case it doesn't give us nice numbers, because it's not as nice as the first one, and it's still gonna take us more time. So it's just better to stick with this method if the numbers aren't that nice. Now, finally, the last one. So I to the power of 301. So let's just divide this number by 4 and see what do we get. So we get 75 plus 1. That is equal to, so 4 times 71 plus 1 is equal to 301. And again, this is the second case, because the remainder is 1, and in this case, the answer is I. So, yeah, as you can see, this method works pretty well. And yeah, so that's it for this video. I hope this helps. Make sure to like and subscribe the video for the future videos so you will be able to watch them. Thank you.